All right, some selected homework here. I know some kids will struggle with the first one here because just notation, man, notation. So let me look at 3. The way this works is this is column 1, sorry, rows and columns. Row 1, and then that last number is column 3. So row 1, column 3 in matrix B. It's going to be a 7. That's how it works. I guess I'll do 4, although you should really be able to do it in your head. You're supposed to find twice A. So I'm going to take everything in A and I'm going to double it. All right. 2 times 4 is 8. 2 times 1 is 2. 2 times 0 is still 0. 2 times 7 is 14. 2 times 3 is 6. 2 times 5 is 10. And I'm supposed to subtract 3B. So I'm just going to triple everything in here. This is called scalar multiplication. I'm going to get negative 6, 12, 21. I'm going to get negative 15, 3, 9. I'm not going to try and do it in my head. And now I'm going to subtract like positions. 8 minus a negative 6 is 14. 2 minus 12 is 10. Negative 10, sorry. 0 minus 21 is negative 21. 14 minus a negative 15 is 29. 6 minus 3 is 3. And 10 minus 9 is 1. Don't be the kid who doesn't get this because you can't add or subtract. All right? I don't want to do 4. I actually don't want to do a whole lot of these. I really want you guys to do more of this yourself. Let's see here. Given matrices X, Y, and Z, calculate the following if possible. If not, state why. You can only do this if things have like dimensions. Like you can't do number 7. They're not the same. One of them's a 2 by 3 and one of them's a 2 by 2. Invalid dimensions. But let's do 9. Nah, let's not. Let's do 7. 7's a harder one. So a segment has endpoints E at 5, -1 and F at 6, 11. Use matrices to represent a translation 4 units down and 3 right. So here's my original image. Call this the pre-image. Been a while since I've done matrices and coordinate points, but I believe that this is X, this is X, this is Y. And this would represent point E. Point F would be 6, 11. Now, what we're going to do is we're going to translate it 4 units down and 3 units right. So we're going to add translation matrix. 4 down, let's take away 4 from Y, 3 units right, add 3. This is the translation. Now we're just going to do the matrix addition. 5 plus 3 is 8. 6 plus 3 is 9. -1 take away 4 is -5. 11 plus a -4 is 7. There you go. This would be the image. That's the words we use for them. Pre-image, the translation, and the image. Use matrices to represent a dilation by a scale factor of 7 centered at the origin. I need to insert of part 1. So I'm just going to do a scale factor of 7. I'm going to throw a 7 in front of that bad boy. I'm just going to 7 everything. 7 times 8 is 56. No. Just go back to the original one. No point in doing all that. Let's go back to the original one. Anyways, 7, the original matrix that you made. 35, 42, -7, 77. I'll be done with it. Let's see here. The fun part of this stuff is actually 9 and then stuff on the back. And I'll do number 8. Shouldn't be too bad. It's actually really, really easy. My augmented matrix, and I'm actually going to move this equation up. It'll be 5, 0, -25, 5, 6, -7. If you're wondering why I moved the second row up, it's because my first row operations, row 1 is going to be row 1 divided by 5. So that's going to give me 1, 0, -5. And the reason I did that is because I had a goal. My goal in mind was 1, 0, a constant, 0, 1, a constant. And I've already satisfied the first row now. This is 5, 6, -7. I need a 0 here. Row 2 is row 2 minus 5 row 1s. And that is a row 2 operation, has 0 effect on row 1. But 5 minus 5 1s is 0. 6 minus 5 zeros is still 6. -7 minus 5 5s is 18. And my last row operation is that row 2 is row 2 divided by 6 because I want a 1 there. 1, 0, -5, 0, 1, 3. So x is -5 and y is 3. Row operations is basically the elimination method. That's what it is. It's the elimination method without doing substitution. It's easy to program too. You know, your calculator's got that RREF thing on it. Yeah, I guess I'll do 10. Because why not? I'm doing the hard ones for you. I'm going to go ahead and put this guy in row 1. The rest of them I'm not too worried about. The reason I put that guy in row 1 is because there's supposed to be a 1 here. This is supposed to be a 0. That's supposed to be a 0. All right? So my first row operation is that row 2 is row 2 plus 5 row 1s. And while I'm at it, I'm also going to do that row 3 is row 3 minus 3 row 1s because I also want a 0 here. And I'm trying to save space on paper. So anyways, -5 plus 5 1s is 0. 4 plus 5 4s is 24. -3 plus 5 -3s should be -16. And -26 plus 5 18s, that's going to be -26 plus 90. That's 64. Yeah. Row 3 is row 3 minus 3 row 1. So 3 minus 3 1s is a 0. 1 minus 3 4s should be a -11. 1 minus 3 -3s should be a 10. 30 minus 3 18 should be -18. Nah, hold on a second on that one. That one's wrong. 3 18s is 54. It's -24. It's easy to make a mistake on these things. 30 minus 54 is -24. Yeah, I'm okay with that. All right, time to move on with my life here. Start thinking about things we need and how to get them. That's the big thing. How do we get them? And hopefully Mobreath hasn't made a mistake. In fact, let's go ahead and check and see and make sure I haven't made a mistake. I'm going to pause this while I check. All right, I was just making sure the matrix was good. This guy is pretty important to me. I want it to be a 1. And the easiest way to make it a 1 is to let row 2 be row 2 divided by 24. And it is going to introduce fractions. These fractions should clear themselves out. This thing is supposed to have nice whole number answers. All right. If you do negative 16 over 24, I'm pretty sure you get negative 2/3. This is a situation where we don't use decimals because you would round. I know some of you, thinking of Taylor, loves decimals. Don't use them because you'd round them. And if you take 64 and divide it by 24, you'll also get a fraction. What is she? 8/3. Now this has to be a 0 and that has to be a 0. All right. So row 1 is row 1 minus 4 row 2's. And while I'm at it, row 3 is row 3 plus 11 row 2's. And I'm pretty tired, so I'm probably going to use a calculator for a good bit of this. But 1 take away 4 zeros is still a 1. 4 take away 4 ones is the 0. And the next thing is there's a negative 3, that's my element. And I'm taking away 4 negative 2/3. Negative 1/3 when everything is said and done. I did exactly what it said. And I've got 18 take away 4 8/3. 22/3. Row 3 is row 3 plus 11 of these. So 0 plus 11 zeros is still 0. Negative 11 plus 11 ones is a 0. And then I got to do 10 plus 11 negative 2/3, which is going to be 8/3 and everything is said and done. And I got to do negative 24 plus 11 8/3. 16/3. Now, this guy is supposed to be a 1. So row 3 is row 3 divided by 8/3. One. What's 16/3 divided by 8/3? She's going to be a whole number. 16 over 3 divided by 8 over 3. 2. Now I'm starting to get in business. Okay? I am. This is where the whole number should start showing up. This is supposed to be a 0. That's supposed to be a 0. All right? Row 1 is row 1 plus 1/3 of row 3. Row 2 is row 2 plus 2/3 of row 3 because I want these zeros to cancel out. We're almost done. Just copying down the last row. All right, so if I take 1/3 of 0, 1 plus 1/3 of 0 is 0. 0 plus 1/3 of 0 is 0. Negative 1/3 plus 1/3 of 1 is a 0. That was my goal. And now I'm doing 22/3 plus 1/3 of 2, which is just 2 over 3. Or, I don't know, but you guys are kind of bad at math. I'm going to write it like that. It's 8. All right. 0, 1. Negative 2/3 plus 2/3 of 1 is 0. And now I've got 8/3 plus 1/3 of 2 again. Oh, I didn't type that in right, did I? 8/3. I'm using a calculator. It's kind of throwing me off here. I wouldn't use a calculator on this usually. Sorry, it's supposed to be 2/3, isn't it? Thirds plus 2/3 of 2. There we go. 4. Whew. X is 8, Y is 4, and Z is 2. And that's actually the longer one. Hope you enjoyed. I actually enjoyed doing it. I used to love that stuff, but I like calculations. I'm like a little computer.